Respected dignitaries, participants, experts, power plant operators, good morning to all of you. Look at this picture very carefully. What is wrong with this? It tells a lot of stories. No, this is a plant, and see all this buckstay was it was locked. I found it at several locations, and I was just carrying a walk down on this unit, and they had a lot of BTLs, boiler tube leakages, and they had made some analysis, root cause, whatever they say, and none of them had pointed out to this, and this was the root cause. They had restricted the expansion even of the tubes and other things, and they were having leakages. That kept it locked, and this is after 1.5 months of overhauling. Then there is another picture I'll tell you. Right hand side, they had locked the pipe. And piping failures, it's huge. And see what happens, it's all connected. It's not one area you take care of and you talk of. Even the hangers, I found some of the hangers, they had just sagged. And it's since long. And then actually every time there used to be condensate in that pipe. Because there is a slope as per design, and then the drains are designed accordingly. And if there is a sag this side, it won't drain. Some water will always be remaining here, condensate. Every time there will be a hammering. And that does a lot of damage to your boiler tubes and other things. All those things you need to take care of. That is why I was telling you the first slide, with O&M practices, you can benefit a lot. It's not that straight away you go to the OEM, change this thing, they'll tell you, okay, change your burners and other things. Similarly, see, expansion and all. Even that pipe. This is some of the common, I think people know that. And flexible operation, these are some of the common problems. Efficiency, it's all interconnected. So, burners and all, I'll discuss these things in details in the subsequent slides. Next, please. So damage mechanisms. You need to understand what are the mechanisms and which mechanism is active at your plant. It's not same, there are many. So you need to go into details in your plant, analyze it with data, long-term data. You collect, typically when we go and conduct study, we ask for 10 years data, which many plants are not able to give, whatever it is there. Even 3 years data can give you a lot of information. And then you can even analyze the pattern. What are the damage mechanism and what is the pattern in particular area. This sort of analysis, I think many plants are not doing. Asset integrity management. And everything, even the drawings in AutoCAD, they are loaded, and damages, they are just pinpointed. And if you have this for 10 years, and even what are the works, even thickness measurements, then your hardness, all those things are recorded. And there's a change of color in the tubes. So you get that information, and then you can, any shutdown or any inspection, you can check and you can tailor your activities to that area. It saves a lot of outages, lot of your efforts, lot of your money. So next. I'll just show you some of the failures, pictures. Some real which I had taken. This one, boiler means cracking. And this is another failure, then blade. So I'll stop on some topic where I'll discuss in details. I think this is fairly known, so I won't spend time on these things. These are some of the damage mechanisms which is understood. Again, temperature transients. This is very common, and I think it is understood, but how to control it, that is a challenge. So all these damages we had analyzed, and with long-term data, we pinpointed it that, okay, this is the reason. There was a very good correlation with that data. ESP collapse. They were not maintaining the acid dew point, means flue gas outlet temperature, they were maintaining below the acid dew point. Long term, and all those data was correlating. And then the ESP had collapsed. What are all failures? Means short term overheating and even long term overheating. Damage in the turbine seals. You are not maintaining your steam quality. Scale deposits. They are all connected. Now, tell me how this is related with flexible operation. Because even in normal, how we segregate it, with the cycles, all those things get changed. Even water chemistry, you need to take care of your oxygen ingress into the system in water. Every time you are taking makeup and other things. For base load operation, okay, you fixed everything, fixed your chemistry. it's running. But with flexible operation, you need another approach. And chemistry also, a lot of failure happens in the cycling plants. PA fan stalling. This is one blade which has broken. You know, it's a challenge when you reduce the load at 40% and you try to keep both your PA fans in service. This is what is going to happen maybe in some of the plants. See, another problem is, I'll tell you the biggest problem when somebody asks me, is the mindset. Operator's mindset. You know, or conservative mindset. Because you don't want to do new things and like whatever is your experience, like I have 35 years of experience. I told her, okay, I've learned all those things. Is it gone? Don't want to listen to new things. So I had struggled initially. I know people from even NTPC were there. We had done initial test runs on the pilot, keeping more number of mills in service. And we were able to test it, even we did it at Mauda. And one key point that was there, we reduced the number of mills in service, 3 mills. There was a lot of resistance. Okay, what if some mill trips? The boiler will trip. I told, if you keep more number of mills, boiler will surely trip because you are going into a lean zone. And even you are in an unsafe zone. You are compromising on the safety of the plant. So with 3 mills, and then after that, we did it first at Dadri, then at NTPC Dadri, and then I conducted around 17 test runs. Recent ones also we did 2 months back in one of the plants in Chhattisgarh. And supercritical unit, and we were able to achieve 41%. First trial, we'll do another trial again. First of all, you need to ensure the reliability of your equipment. Just because your equipment is reliable, it doesn't mean that there's a problem with low load operation or flexible operation. This is one place where the entire bottom ash hopper, they had collapsed, exploded. Not once, 17 times. 2 units. This is a plant in South India. I won't mention the name of that plant. They had exploded 17 times, and then a lot of like even OEMs, they had conducted the study. The supplier was BHEL, can name that. Then somehow I was there, we conducted the study and we identified the root cause. And it was very simple. They just changed the operational procedure. After 1 year I got the call, sir, thank you. I told, what for? I told, this didn't explode anymore. I told, it shouldn't explode. So they just changed that operational procedure.